Thank you, Virendra-san. Welcome all for the post-lunch interesting sessions. We now go on to session 3, Enabling Technologies Industry 4.0. We have 3 eminent panelists on this platform. Mr. Ravi Agarwal, Managing Director, Pepperl+Fuchs Factory Automation Private Limited. Mr. Ajay Gopalswamy, CEO, DiFacto Robotics and Automation Private Limited. Ms. Marcia Gadbois, President and GM at ADDISRA LLC USA. Welcome you all. I request Mr. Ravi Agarwal to take us through this session. Just a brief on Mr. Agarwal, Managing Director, Pepperl+Fuchs Factory Automation. President, Automation Industry Association, Director, Foundation for Smart Manufacturing at IIT Delhi. Currently functioning as the Managing Director, Pepperl+Fuchs FA in India, and looking after business in the Middle East and India. Leading the organization for its foreign business in the field of sensing, machine vision, and automation solutions for the manufacturing environment. Widely traveled and worked at different national and international locales with multiple industrial segments, machinery OEMs, end users, designers, and manufacturers. Director of Foundation for Smart Manufacturing under the Samarth Udyog program of the DHI, Government of India. FSM aims to promote better understanding of the concepts, technology, and extend the relevant skilling and help to the Indian manufacturing sector for the better adoption of Industry 4.0 concepts and for increasing the participation in the global market. As a president of the Automation Industry Association that works for proliferation and proper assimilation of automation in manufacturing ecosystem in India. It leads the automation industry with its market, government, and education connect programs. Welcome, Mr. Agarwal, and over to you, sir.
Thank you for the profuse words, Deep. Good afternoon, everybody. It's indeed an honor to be part of this session. I thank CII for organizing such an opportune and a useful event for the benefit of the Indian industry. And I welcome my co-panelists, very eminent personalities, and I'm sure that the journey which we started in the morning, we're going to take it forward in the subsequent hours. It was indeed a pleasure to listen the galaxy of experienced people and leaders in the morning, how different facets of Industry 4.0, technology, its application, its usage, can actually how the spread is and how vertical and horizontal spread of it may benefit really the people. However, taking it forward in context of India, a country like India is actually in a very unique position. India has survived centuries by one concept. The people in this land actually absorb what is good coming from different shores and geographies of the world, amalgamate it into our own lifestyle, learn from it, spread the better part of it, and elevate our society. And I think Industry 4.0, its concept and products, technologies, would fall in the same league. Indeed, as in the morning session, different technologies came about. Different tangible and intangible benefits came about. I believe with all the data, with the machines, with the human beings, actually will accelerate the development in India. Not only accelerate, it will help us to leapfrog certain weaknesses in a rapidly urbanizing society in modern context we are. Looking at this conference itself, we are transcending the infrastructure and sharing our views across the globe with a lot more reach. And I believe that all these concepts and Industry 4.0, we can call it from German part Industry 4.0, from USA, IIOT, and then Chinese and Japanese have different perspective to it. But I think the essentials of it, the soul of it actually remains the same. And I do believe that there is a larger good for Indian manufacturing, Indian people, and society. That in India, not only are we talking about Industry 4, Industry 3 and Industry 4 in India actually is rolling out simultaneously. Thereby, the cost of learning, cost of implementation, actually we have a unique position to circumvent it. And as I say, most of you are already knowing the prowess, what by demography, by expertise, by education, by age profiling, the edge India has, wherein the data from human population, human aspects, environmental aspects, machine aspects can all be collated together, and that comes under the umbrage of IT. And herein lies the confluence of what the machinery, infrastructure, people, and IT can bring all about. So not only can India actually benefit from it, but India can take it forward by much more vertical and horizontal spread of it and implement or help in implementation of Industry 4.0 throughout the world. Having said so, one of the important aspects remains that as we move forward, we must also grasp all the products and technologies which are in the umbrage of Industry 4.0. And I guess today afternoon, I have the privilege of having two of my colleagues, co-panelists, who are going to throw some light into some of these technologies which are of high importance, use in implementation of Industry 4 concepts as such. I would first invite a very learned person, Mr. Gopalswamy. Mr. Gopalswamy is a mechanical engineer by training and has specialized in what else but robotics and controls from University of Carolina. In fact, Mr. Gopalswamy, I'm so very inspired, Even in the early 90s, you have worked under the DRDO and right spot on the topics of artificial intelligence and robotics. And from those rich years of experience, Mr. Gopalswamy has actually worked with ABB, Fanuc, Int'l, and has been at the heart of affairs as far as robotics is concerned. Mr. Gopalswamy is actually also the co-founder of a very, very known company, DiFacto Robotics. And DiFacto Robotics is doing its good bit of work in the Indian ecosystem as far as robotics and cells and implementations are concerned. But what is worth noting is not only is DiFacto adding value to the Indian ecosystem, he and his company are actually working with international brands like Tesla, Bosch, GE in order to put the technology forth, realize the best benefits of these applications. It's an honor to have you today, Mr. Gopalswamy. The floor is yours.
Thank you, Mr. Ravi Agarwal. Thank you for your very kind words of introduction. Really honored to be a part of this session with eminent co-panelists such as yourself and Miss Marcia. I hope you can hear me well. Okay, great. All right. And also my other co-panelists, Mr. Virender, the CII team, thank you all. And I see a very good participation, about 160 plus attendees. And most of them, I also have a button where I can see how attentive they are. So I can see that more than 50% are attentive. So that's good news. Yes, thank you for your kind words. I just also wanted to add to your introduction and say that I had the honor and privilege of interacting with Dr. Abdul Kalam when I was briefly in DRDO. And it was really, when I look back, I think that was one of the highlights of my career. So, so I will not take more time. I will be talking about autonomous mobile robots. Let me see if I can pull up my screen. Yep, should be able to see my screen now. Yeah, okay. Good. So this is a very autonomous mobile robots is a new and emerging field and is going to play a very, very important role in Industry 4.0. So I'll take a few minutes to talk about this because it is going to be a very important technology in manufacturing going forward. I'll just briefly talk about what AMR is all about. I'm going to use the short form AMR when I talk about it. Let me just go to my. So before talking about the technology, I just want to give a brief introduction. So Ravi Agarwal has already talked about it. So we are an Indian company based in Bangalore. We have branch offices in Pune and Gurgaon to serve our customers there. We are an ISO 9000 certified company with more than 250 employees. We also have our subsidiary in Michigan in the US where we serve our North American customers. The industry segments that we serve is mainly, you can say, automotive forms our biggest. The automotive serves as the biggest customer base. We also have customers in aerospace and defense, electronics, food and pharma, construction equipment and machinery, metal industries, foundry and casting shops, home appliances and energy. So with this brief introduction, let me move on to what is an AMR. A lot of us are aware of an AGV. AGV is an automated guided vehicle. It's a computer-controlled, electrically driven vehicle that follows a predefined path with minimal or no human intervention. And autonomous mobile robot, it's also a self-driven vehicle, but it has the intelligence to change the path within certain constraints, of course, when faced with new or unexpected situations. So this is the difference between an AGV and an AMR. So in AGV, you have a fixed path, and if there is an obstacle, the vehicle will stop. It can't do anything else. Whereas an AMR can possibly try to avoid that obstacle and go around it. So advanced software features allow AMRs to have the ability to learn as they encounter new situations. So let's take a look at how AMRs can be deployed. And I'll just talk about 3 case studies that my company has been involved in with AMRs. One is an inspection machine load unload application. The second one is a machine tool load unload simulation study, which was one of our clients asked us to do. And the third one is a large AMR system in the glass industry. So when we so this particular application of load unload of inspection machines was for our esteemed client in the US, GE. This is for their aviation group. So they have this plant in South Carolina and manufacture turbine parts. So this each part is, because it's so critical, every single one of them have to be inspected 100%. And GE has developed their own technology for the inspection. I'll show you a short video soon. So this technology uses the CT, computerized tomography, which is also used for scanning our bodies. It's like GE is one of the world leaders in CT technology. So they use the same technology to inspect each and every part which goes into their aircraft turbines. So the parts are picked from and loaded into the CT machines. And the big advantage of this system was there were no plant changes required. The system was commissioned in a matter of days. So this system had an AG, and you can say an AMR. This is the base AMR, and on top of that, the robot is mounted. So the robot was a Fanuc LR-made cobot, 7 kilogram payload, and it has a controller. So the power supply to the robot is given from the vehicle itself. And DiFacto's role was to supply the structure, the cart. We used a standard AMR from a company called Otto in the US. Actually, it's a Canadian company. And we integrated the robot on the AMR, and our partner Capriol, which is an offshoot of GE, did the software development and the implementation at the site. So this is a short video. So this is by the company itself. But it's in North Carolina, not South
When
Carolina.
we first came to GE Aviation Nashville, we were looking at processes that took around 20 to 30-minute cycle times with operators that were highly trained and having to do jobs like moving material. The plant was looking for a way to increase productivity and also scalability. The solution was to automate their process. This relieved the highly skilled operators from having to move the material around the plant.
We worked hand in hand with inspection technologies and Capriol to integrate a fully automated solution that we call the M225 and mobile machine.
Fun to be the first.
Okay. So this was the application. There were, I think, 4 CT machines and 2 AMRs catering to those 4 machines. In this particular case, the inspection cycle was about 10 minutes. So plenty of time to do that. And the customer was very pleased with the end result of the deployment of the AMRs. The second case scenario that I want to present to you is a machine tool load and load application. This is a little bit, this is a more traditional robot application where you have robots on a track, a floor-mounted track, or a gantry system. But the customer wanted to have more flexibility, so the customer commissioned DiFacto to perform a simulation study using 2 robot configurations for load and load, traditional robot mounted on floor rails or overhead gantry, and using AMRs. Okay. So we did this, we built the layout in the virtual world for all the scenarios. So this is the traditional scenario with the floor mounted robot, and this one is with the gantry, overhead gantry. So the The pros and cons of the traditional machine tool load unload systems are extremely high speed. So at this point of time, it is not possible for an AMR to match the speed of a traditional robot mounted on a gantry or on a track. There are two reasons for this. One is because, as you can see, the entire system is fenced off over here, so the operator doesn't enter into this zone. So that allows the robot to travel at very high speed. So it is suitable for high production volumes and where there are low number of variants in the parts we manufacture. The downside of it is it's a very rigid layout. So if you want to change something, then it's a real pain, because you have this gantry or the track, you can't, and they have to be perfectly aligned. All the machines have to be aligned. If you want to change, then you need to do a lot of investment once again. So it's a very rigid layout. We also did a study with an AMR. So as you can see, the layout becomes much more flexible. You can have a cluster type, 4 machines back to back. You can divide them into different aisles, and the AMR can pass through the aisles and load and unload the machines. Having said that, these are suitable for high cycle time machine parts. So it's not really for like fuse half a minute or 40 seconds, 45 seconds. Those kind of cycle times will not suit an AMR at this point of time. These will be suitable for 2 minutes plus kind of cycle times. The advantage is extremely flexible layouts, and excuse me, and they're amenable to adding or changing the machines. Allows the operators to work in collaboration with AMRs. Don't have to have a fenced area. So the setup is very fast. You don't need to align anything. You don't need to fix anything to the floor. It's all using the traditional industrial shop floor space. This is a video which shows the application. Excuse me. So as you can see, the AMR is able to move around the machines. They can be programmed. You can add an AMR. Now we are showing 2 AMRs. If you have higher production rates, you can increase the number of robots there to achieve the cycle time. So it's a very, very flexible concept and most suited now for high cycle time operations. Okay. Excuse me, I have a bad throat and my apologies for that. So the third case study that I want to present to you is the large AMR system, which was also for one of our esteemed customers in the US, which is used for unloading glass billets from presses, which have a very long lead time. So the existing plant was not suited to standard automation, since the presses are not easily moved. Once they're fixed, it's pretty much fixed. So the AMR helps solve their issues. You can see that this is a large robot with a payload capacity of about 100 kilograms. And the AMR itself is capable of holding the robot as well as the controller. So it's about 1.5 ton capacity. Okay. So in summary, I just want to say that the deployment of AMRs is likely to grow, because this is just the beginning of deployment. There are many applications. AMRs are used very typically in warehousing and logistical operations. But I do believe that manufacturing is ripe for adoption. The innovative integrators can use AMRs to solve customer issues. Costs will drop, as it has happened with traditional robots also. As the volumes increase and software advances, the safety standards will continue to evolve and will help to reduce redundant safety scanners. Safety is a big concern with AMRs, but technologies are rapidly evolving, and it will allow collaborative work with human beings. And lastly, mobility and flexibility of AMRs will help in the ultimate goal, which is lights out manufacturing. This is already happening in many Western worlds, but I think it will also happen soon in India. I mean, we are already working on a pilot project with one of our customers in India, where we will be attempting to deploy it for a 24/7 operation. With this, I end my presentation. Ravi, if you want to have any questions now or you want to do that later, it's fine by me.
Thanks for the wonderful insight, Mr. Gopalswamy. I guess we share the technologies as we have to present, and thereafter we can take some questions from the participants on the areas of their field of interest. So my compliments. In fact, AMRs today, generally men are fanciful of toys, and having an AMR in a factory, is like for we work people a dream come true, because we have a toy and that toy becomes our work as well.
Yeah.
But I believe AMRs are doing a wonderful job, and they are actually a sunrise solution to the flexible manufacturing systems. I would be very interested further to learn from you. Thanks for sharing those insights.
Sure.
And as we move forward,
we'll talk later. Yeah, we'll take some questions later.
Sure. I would hence move to another eminent panelist in the session, Miss Marcia. Miss Marcia joins us from US, and probably it's exactly opposite of the daytime out there, if I'm not wrong. So that's a big motivation on the program, and so much proactive participation. Thank you, Ms. Marcia. Ms. Marcia, I must share with you, she holds specialization in management information and computer sciences from Bowling Green State University, and also has an executive MBA from New Hampshire. Not the least, Ms. Marcia is a contributing author in the book Client-Server Programming with PRC and DCE, and she has authored many articles and white papers. She has held a number of high-tech senior management positions in multiple areas of business, development, strategy, competitive intelligence, sales, and marketing. She has more than 3 decades of experience in the software industry, very specifically in the manufacturing domain, touching the world of SCADA, HMI, artificial intelligence, rapid application development environment. I think that's a very, very important aspect. So on and so forth, not to say the least, a wonderful, wonderful experience in industrial automation. Ms. Marcia is an entrepreneur and is running a very successful startup called ADDISRA. Now, on a personal note, ADDISRA stands for, as I've been told, aware, diverse, integrated, self-regulated, and adaptive. I must compliment, that's a very encompassing perspective on how things are, and especially as you play a pivotal role, how technology, the perspectives of how you have named your company after, comes together for the benefit of the humankind. It's indeed an honor, ma'am, to have you. Welcome, and the floor is yours. Ma'am, you are on mute.
I've got it. I hope everyone can see my screens. Okay, perfect. Let's get started. Thank you very much for the opportunity to speak at this conference, and I'm honored to be speaking with such a great panelist, and so I appreciate it. As I said, my name is Marcia Gadbois, and I'm president of ADDISRA. ADDISRA is a software company that offers HMI SCADA called ADDISRA SmartView, OEE and Advanced Analytics called ADDISRA Insight View, and predictive maintenance called ADDISRA Knowledge View. ADDISRA, in partnership with Beta Vega, offers these solutions to the Indian market. Oops, let me see if I can, okay. Yeah. I'm going to change the conversation to be a little bit more software oriented, and we're going to talk about data and our journey for data analytics. So data acquisition strategies have been evolving in the area of COVID-19. It's driven by increased requirements for remote data visualization and actually real-time data decision-making. Before big data analytics and everything was happening, companies were collecting and storing lots of data in databases, not knowing exactly what to do with them. The problem is that as businesses grew, their business critical data became fragmented. Data is scattered across all kinds of applications, and the need for big data occurred. According to Gartner research, the average financial impact of poor data on organizations is 9.7 million per year. Interesting enough is IBM stated that in 2020, every person generated 1.7 megabytes per second of data. And that number is just increasing as we deploy more sensors and we employ more sensors and controllers throughout our organization. According to Statistica, data creation will grow to more than 180 zettabytes by 2025. Some of the reasons for the spike in the data collection is that the pandemic has introduced a new way of us working. We're now working more remotely, and we're also wanting more data to be rich with video and audio. Video and audio is called unstructured data, and according to Forbes, 95% of businesses cite the need to manage unstructured data as a problem for their business. In a digitally powered economy like ours, only those with the right form of data can successfully navigate the market, make future predictions, and adjust their business to fit the market trend. So let's talk a little bit about structured and unstructured data. All data is not created equal. As mentioned earlier, some data is structured, but most of it is unstructured data. Structured and unstructured data is sourced, collected, and scaled in different ways, and each one resides in a different type of database. Structured data, typically categorized as quantitative data, is highly organized and easily deciphered by machine learning algorithms. Since structured data predates unstructured data, there are more tools available for using and analyzing structured data. However, 80% of all data that we generate is unstructured data. Unstructured data, typically categorized as qualitative data, cannot be processed and analyzed via the conventional data tools and methods. Since unstructured data does not have a predefined data model, it is best managed by non-traditional databases such as Hadoop or NoSQL. Examples of unstructured data include text, mobile activities, video, audio, social media posts, industrial Internet of Things sensor data, and more. The biggest difference between structured and unstructured data is the ease of analysis. new tools are available to analyze unstructured data such as pattern sensing, classification, text mining algorithms, just to name a few. Organizations need to mine both structured and unstructured data in order to achieve a true digital transformation. It's hard to know where to start in the data analysis journey. This slide shows one approach based on Six Sigma Dmac methodology, which stands for define, measure, analyze, improve, and control methodology. A good beginning is to have a clear objective of what you want to do with the data, like a concrete question to answer. Once you have the goal, it is time to collect the data from as many sources as possible, including the structured and unstructured data. The next step is to cleanse the data. Remember, insight and analysis are only as good as the data you're using. Data cleansing is the process of fixing or removing incorrect, corrupt, inaccurate formatted, duplicates, or incomplete data within a data set. When combined with multiple data sources, there are many opportunities for data to be duplicated or mislabeled. If data is incorrect, outcomes and algorithm are unreliable. This stage is not about biasing the data, but merely cleansing it for use. Once you have a nice data set that's clean, it helps to visualize the data to be able to explore and communicate your findings. After the visualization, the next step is applying algorithms and machine learning. Applying algorithms and machine learning allow you to get more insights from your data. And the last step is continually evolving your model. According to O'Reilly, a consulting firm, one of the biggest mistakes the people make with regards to algorithm and machine learning is thinking that once a model is built and it goes live, that it will continue working normally indefinitely. Models actually degrade in quality over time if they're not continually improved and fed new data. As industry trends change, the model will have to account for these changes. So basically, I'm going to talk about learning. So there's supervised learning and unsupervised learning and semi-supervised learning. But algorithms are the engine of the machine learning, meaning that algorithms turn a data set into a model. Which kind of algorithm works best, whether it's supervised, unsupervised, classification, regression, depends on the kind of problem you're solving, the computing resources available, and the nature of the data. There are many different types of algorithms used in machine learning, such as neural networks, Bayes, and k-means clustering. Each algorithm is unique and has its own strengths and weaknesses. For example, some of them excel at finding hidden patterns in data, such as our online shopping habits. I'm sure you shop online like I do, and it starts to recommend things to you. While others are able to take images and classify them on a very large scale, such as Google Photos. So we tend to group algorithms by learning styles, such as supervised, unsupervised, and semi-supervised learning. With supervised learning, an algorithm is presented with a set of inputs along with their desired output, which we call labels. The goal is to discover a rule that enables the computer to essentially break down and learn what the inputs is mapping to in the input to the output. For example, categorizing images of robot to teach an algorithm what a robot is. The model would be presented with lots of different types of robots, and each image would be labeled as robot. The goal is to distinguish a robot from other devices like a controller or PLC. Supervised learning is like decision tree, backpropagation, random forest, and logistics regression. While unsupervised learning, an algorithm is presented with a set of input, but no desired output or label. which means that algorithms must find structure and pattern on its own. For example, if images of robots were fed into an unsupervised algorithm, each image would not have a label that identified it as a robot. Instead of being told what the image is, the algorithm would have to find patterns on its own as it assessed the thousands of images, and it would classify the image based on a pattern discovered. For example, the pattern could be the type of robot, like the height, which we saw before, or the number of arms, or whether it was stationary, mobile. And semi-supervised, as I mentioned, is a hybrid of both supervised and unsupervised learning. I think it was Thomas Jefferson who said the immortal words, "Not all analytics are created equal," or something like that. In this presentation, I'm just going to focus on 4 dominant types of data analytics. Each of these analytics types are different, bring you different insights. Descriptive analytics answers the question of what is happening. Based on real-time and past data, it garners insight on how the process is performing by providing context to the data. Diagnostic analytics builds on descriptive analytics to answer the question, why did this happen? Diagnostic analytics uses statistics to find patterns to offer insight into the real-time data. Root cause analysis is typically used for diagnostic analytics. Predictive analytics builds on diagnostic analytics to answer the question, what will happen in the future and why? Predictive analytics seeks to leverage the same historical data to build mathematical models that can be used to make inferences about what will happen in the future. There are several tools used for predictive analytics, and we will go into that later in this presentation on some of them. Prescriptive analytics builds on predictive analytics to answer the question, what is the best solution or outcome given the known parameters? How should we respond to those potential future events? The prescriptive analytics approach analyzes potential decisions and interacts between the decision and influence upon figuring out what course of action should be done. So it's really looking at the course of action. All analytics is subject to the same data distortion that can upend any of these analytic methodologies. So you always have to look whether it is. I like to think of descriptive and diagnostic analytics as looking in my rear view mirror on my car, while predictive and prescriptive is looking into a crystal ball. Descriptive analytics is the simplest class of analytics, one that allows you to condense big data into smaller, more useful nuggets of information. Descriptive analytics or statistics does exactly what the name implies. They describe or summarize raw data and make it something that is interpreted by humans. They are analytics that describe the past. The past refers to any point in time that an event has occurred, whether it's 1 minute ago or 1 year ago. Descriptive analytics are useful because they allow us to learn from the past behavior and understand how they may influence future outcome. Common examples of descriptive analytics are reports that provide historical insights regarding the company's production, financial operations, sales, finance, inventory, and customers, for example. Tabulating a success of a marketing campaign by the number of Facebook likes, tweets, or followers is one way of aggregating descriptive analytics. Two common tools for descriptive analytics is data aggregation, which presents data in a summarized format, and data mining, which finds meaning or patterns in a data set. Descriptive analytics method is meant to provide strategic insight into your data set for better decision making. It can also help you improve the design of your process by providing insights into what went well and what did not go so well in your process. The purpose of data aggregation is to reduce the number of attributes in object and change scale. For example, aggregation like cities can aggregate into a region, could aggregate into a state, could aggregate into a country. Also, data aggregation tends to have less variability, so it reduces the effect of the random noise. A business learns from the past behavior to understand how they will impact future outcomes. So descriptive analytics is used when businesses need to understand the overall performance of the company as an aggregate level and describe the various aspects. Diagnostic analytics is a deeper look at data to attempt to understand the cause of an event and behavior. Diagnostic analytics takes descriptive analytics a step further and provides deeper analysis to answer the question, why did this happen? Diagnostic analytics is referred to as root cause analysis or correlation between variables. Correlation looks at what is causing this behavior. You would usually pick out a bunch of features that you think might impact the behavior, then find the correlation between them. Correlation coefficients are used to measure the strength of the relationship between the two variables that you picked. So correlation greater than 0 indicates a positive relationship, while a value that is less than 0 is a negative relationship, and a value of 0 indicates that no relationship exists between the variables that you pick. For example, the correlation between security rating and the number of incidents is one example of a way of correlating stuff. Diagnostic analytics. So once again, diagnostic analytics is why things happen and what is causing things to go on. That is really what it's all about. It's an exploratory phase. Visualization and KPIs are important in the exploratory phase. KPIs establish a common data-driven language within enterprise and identify trends, thresholds, anomalies, and other metrics that lead to the subsequent question of why something happened. Predictive analytics can only forecast what might happen in the future because all predictive analytics are probabilistic in nature. Predictive maintenance answers the question, what is happening in the future and why? I will go through 4 of the most common and popular predictive maintenance algorithms. Predictive maintenance is the ability to accurately predict downtime, outage, and failure in equipment, enabling intervention before things go wrong. One of the methodologies used is anomaly detection, as it states here. Anomaly detection refers to identification of items or events that do not conform to an expected pattern or to the other items in the data set. And as you can see, there's a data set on the side and the one point is outside of it. Classification is a problem of automatically assigning a label to an unlabeled example. Classification is only 2-class label. This makes it easy to filter the data, apply the classification algorithm, and train the model to predict outcomes. So for example, spam detection is a famous example of classification. Incoming mail is either classified as spam or not spam. In machine learning, the classification problem is solved by a classification learning algorithm that takes a correlation of labeled examples as input and produces the model that can take an unlabeled example as input and directly put it out as output. As people know, classification is binary and binomial. Multi-class classification, also called multinomial classification, is a classification problem with 3 or more classes. For example, back to my email, let's go to cybersecurity company might want to be able to monitor a user's email inbox and classify incoming email as either potential phish and spam or not. To do so, it might train the classification model on the email text and inbound email address and learn to predict from which sort of URLs threatening emails tend to originate from. While some learning algorithms naturally allow for more than two classes, others are by nature a binomial or binary classification. There are strategies allowing you to take a binary classification learning algorithm into a multiple class one. However, I'm not going to talk about that in this presentation because of time. Let me go with the last one, which is regression analysis, is a set of statistical process for estimating the relationship between a dependent variable and one or more independent variables. In other words, regression is a problem of predicting a real value label, often called target, given an unlabeled example. For example, I'm estimating house pricing valuation based on the house features, such as the number of rooms, where it's located, and this is a famous example of a regression problem. Regression problems are solved by regression learning algorithms that take a collection of labeled examples as input and produces a model that can take an unlabeled example as input and output a target. As mentioned earlier, the model needs to be updated constantly to incorporate new information that may affect the model. Also, I want to point out that no technology, whether it's a machine learning or not, can detect 100% of failure. It is not possible to predict a user error. For example, an employee running into your asset with a forklift. I know this is an extreme example, but it gives you the point across that you can't control all things, but it lets you control a lot. As always, a prediction will always remain a prediction with an inherent shortcoming in knowing the future. However, the British philosopher Carveth Reed said it is better to be vaguely right than exactly wrong. In today's world in big data, a growing number of enterprises are deploying powerful predictive analytics to increase their chances of being right. And last, prescriptive analytics. Gartner defines prescriptive analytics as the application of logic and mathematics to define a preferred course of action. Prescriptive analytics takes the input from predictions and combined with rules and constraint-based optimization enables better decisions about what to do. The decision might be to send an automated task to a human decision maker along with a set of next action steps and recommendation, or send a precise next action command to another system. There are two primary approaches to prescriptive analytics. The first approach is optimization techniques like linear programming, and the second approach uses computational logics like predefined business rules. ADDISRA product offering and ADDISRA's view on digital transformation is an evolution of building blocks, beginning with the collection and visualization of the data. Human-machine interfaces and supervisory control and data acquisition systems are becoming even more important to achieve digital transformation because they can perform analytics on the edge and provide agility and resilience fundamental to success. After the collection and the visualization of data, descriptive and diagnostic analytics to know what has occurred and why. Then predictive analytics that forecasts what might happen in the future. The key to success in the digital transformation is to gain the right information, which delivers knowledge to an organization for better decision making. The whole purpose of this is to be able to make better decisions with the data that you have collected. So that's it. If there's any question, at the end.
Thank you. Thanks for the very, very insightful presentation, Ms. Marcia. In fact, that reminds me, back 3 decades, 4 decades, we were told that computers are as intelligent as the user be.
That's true.
And coming to Industry 4, I would say the real benefit of Industry 4 would and may lie in how intelligently the data is handled, interpreted, and derive the results out of. So
Right.
your entire structure into a building block of how from the field, diagnostic, prescriptive, and predictive, how one after the other in succession can actually really land the benefit to the user. Because the whole idea of Industry 4 is not about connectivity. It is about what do you do after connectivity and collection of data. It is the real interpretation of data and then subsequent implementation of the corrective measures so that the enterprise and people associated with the enterprise and the processes actually benefit from.
I totally agree with your assessment. That's exactly it.
Thanks. Thanks for giving us that valuable insight, because without data, I guess we might be under the illusion that we have so-called taken the panacea of everything and implemented Industry 4, but actually we have just automated the plants and connected the machines, but without data analytics, it's Industry 4 not yet done. Thanks.
Yes, I agree. Thank you.
In fact, as I was building up and seeing various technologies that were going to be presented this afternoon, which actually enable us for Industry 4.0, I was wondering, and in fact, coming from the world of sensing, as some of you may know, Pepperl+Fuchs is actually associated with industrial sensors. And there has been a lot of upheaval within Pepperl+Fuchs about what's going to be the shape, size, performance, and demands on a sensor as the world quickly evolves into Industry 4, its implementation and derivation. Because in the classic pyramid of automation in any manufacturing domain, the classic pyramid, the bottom of the pyramid is all the field devices. And if Industry 4 is a skyscraper, then at the foundation of it are the components which actually make that happen. And I believe a good lot of load actually lies on the sensors, which make all the sensing and data communication with the process possible. So I said, let me take this privilege and try to share a little bit insight into some of the sensors, what Pepperl+Fuchs offers actually in enabling Industry 4.0. May I request for the sharing tab, please?
Am I supposed to do something?
Yeah, Karthik, please share the.
How do I?
You
I'm
sharing the Karthik san, please.
Yes, sir.
Karthik, thank you, but I still don't see the sharing tab.
Done, sir. Done.
Yeah, thank you. I'm on it now. Just a quick check. Is it viewable?
Yes, please.
All right, thank you. As we go about it in any kind of manufacturing enterprise,
Ravi san, your network is having some problem. We are not able to hear you.
Mr. Ravi?
Yeah, they are trying correcting the network. Ravi-san, we are not able to hear you, so to kindly check the network.
So Ravi, you can switch off your video to save bandwidth. Ravi, can you hear me now?
So I take a one question. Meantime, let's from the audience side, I can see the question. This is the question from Dr. Archana again, and to Miss Marcia. Does
Yes,
descriptive analysis imply data acquisition?
it also implies not only collecting the data, it also implies taking the data and doing like OEE and KPIs. And if you add diagnostic, it's the ability to drill down and see what exactly is happening. So it's really not only the collection and the visualization, but the summarization, the aggregation using KPIs and KPIs, OEE, and other metrics like the 6 major losses in your plant or other algorithms. So that's really what descriptive analysis is, while diagnostic is getting to the root cause. I hope I answered your question.
Yeah, thank you. It's great. So next question, how Industry 4.0 is best adapted in steel plant? Yeah, Ravi-san, over to you. We will take the question later on. Over to you, sir. Please.
All right, thanks. I would request for again giving me the sharing tab, please.
Karthik-san, kindly help.
Just waiting for the share tab.
Yes, sir, we can hear you now. Yeah, just. Yes, sir.
I'll just request for the share tab. It's there now. Thank you.
I'll turn it to you, sir.
Just a quick confirmation. Is it visible and audible?
Yes, sir.
Thank you. My apologies for the network breakage. Not in our control sometimes. But to continue, I wonder where I left off or became inaudible. So I'll just try and build the talk again, that any enterprise for that matter actually is oriented around quite common pillars, as I would say, be it supply chain or efficiency or quality, energy, productivity, or visualization, wherein all these processes have some or the other field operation. And in each of the field operation, I guess there is a necessity of something that is physically measuring, monitoring, converting it into electronic data, and then transmitting or communicating. But all of this, I would say, in a very analogous word to Industry 4 is the word cloud. And thereafter, some verticals are calling it a fog also, wherein in a machine to machine or a line to line or a plant to plant or an enterprise as a whole umbrage, is organized around a cloud or a fog. But the important point is the sensors and the sensor systems actually are communicating the desired data. And what is that data? It's about the information on the process or the event, wherein I would rather very simplistically say that the information is actually the bedrock for the Industry 4.0. And as Ms. Marcia already indicated, information is readily interpreted actually from the data. So I would say that there are a lot of technologies today available wherein, whether it's production or quality or a supply chain or a very important issue these days regarding legacy equipment or asset utilization, wherein how can new technologies actually not give an exit to all the legacy and in-use machines, but actually retrofit them and make them ready for the right data to be captured and communicated. Having said so, as from the Pepperl+Fuchs domain, I would say modern sensors are not only required to measure. For decades together, the whole idea of a sensor was more of a binary operation or to measure something. But today, there are two fronts on which the sensor revolution is actually taking place. One is, how is my front-end transducer actually changing? And there are lots of technologies which have developed over the years, enabling and giving more teeth to the sensors as to how a physical process, an event be measured, how the resolution, hysteresis, accuracy, etc. perform. But not only that, how can I actually communicate the data of my measurement effectively? Not only that, how can my sensor actually stand alone and do part of the initial data analysis? Because ladies and gentlemen, what's happening is, if all the data is to be centrally processed, then there's a huge amount of processing load and thereby a delay in the results so derived from. And in actual operational world, in an operating machine, a delay in the analysis of the data coming back as a result may be catastrophic. So not only are the sensors today being demanded to measure and communicate, but semi-processing activity, semi-control activity housed within a sensor, whether it's housed alone, operating alone, connected to a cloud through maybe a wireless network, or operating on the machine, is so very well called off. I have actually tried to allude to the Ravi model here, because if all kinds of equipment start doing all kinds of activity on the manufacturing domain, on the shop floor, there's going to be an utter chaos. What my consolation to the audience is that for a proper implementation, the reference architecture model for Industry 4.0 starts to lay down. It's a work in fancy, it's in process, what each equipment may do. Where in the pyramid? Now, here lies the catch. In the new automation domain in Industry 4, it is no longer a classical two-dimensional model of control and automation as far as industrial automation goes, but it's a 3D cubical model. As you can see, how different equipment may be positioned and what kind of performance may be demanded from a particular equipment, be it a sensor or a field controller or a field communicator or a visualization device. Now, it so happens in the morning also we saw some case examples how that transformation is taking place, how, let's say, different simple processes which collect together to make a manufacturing enterprise, how different measurements are coming together. Mr. Soni so very nicely alluded to a simple measurement of gas consumed in welding gives him a very, very clear indication of what kind of wastage, what kind of energy consumption and throughput is happening. In fact, in one of the companies we have been working with, there has been so much savings, as Mr. Gopalswamy said, lights off manufacturing. This company actually subscribed to electricity at night in the manufacturing area where electricity rates really come down. Having all these sensors, robotics, their ultimate cost savings on the products so manufactured was hugely reduced, thereby making them not only competitive locally, but even go international. That's the power of how different equipments and their data actually come together in landing the real benefits of Industry 4. Just as an example, as a smart sensor might be, if I take a simple ultrasonic sensor, put up a battery and a LoRaWAN module, how can different tank levels or bin levels across a city, if I fit it with a GSM module, come together and actually create or make implementable or enable a smart city concept, how the water supply may be managed, how garbage may be collected, how different civil services can be oriented. One small example I would like to say is, in solar thermal plants, just for an example of a smart sensor, how enablement is going, how communication between one sensor and the other and a decentralized control is helping. This is a picture at the right bottom. It's an actual picture. How different mirrors are positioned and one mirror holds its orientation against the other mirror so that the solar thermal power is concentrated to the center of the focal area, as you are seeing along a pillar, thereby creating thousands of degrees of temperature, which is otherwise not possible manually. Having said so, a very brief outline into how different transducers today are changing. The dinosaur ears of proximity sensors today come to dawn in a completely new avatar, wherein not only one coil but multiple coils with an onboard microcontroller today are actually the pivot, not only to detect but to measure and characterize the target, thereby making the whole manufacturing process highly flexible and programmable at a large speed. Another example where the front-end transducers are changing, and I think that's really creating a revolution, is time-of-flight sensors. Today, the semiconductors are so fast and advanced that actually they can measure speed of light so transmitted and the time taken for the exact beam to get reflected back. And as the speed of light is constant, distance measurement can happen very fast and accurate. If I take this simple process and turn it around and deploy it into the modern day sensors, I can throw a single beam of light. I can actually create multiple beams of light, or I can take a single beam of light and rotate it so that I have a light plane in a particular area. And what you are seeing are actual sensors deployed under modern solutions where such one-dimensional, two-dimensional, and a three-dimensional solutions today are actually working, making a lot of things possible. In fact, Mr. Gopalswamy was talking about AMRs. What makes an AMR actually become autonomous and navigable? Because otherwise, any AMR which is moving autonomously will collide. How do you avoid collision? How do you charter an alternative route? But again, the right medicine for the right solution, we can have one-dimensional, two-dimensional, or three-dimensional solutions, respectively, for the problem actually we are trying to solve. Herein, all these beaming and distance measurement we are categorizing under the very famous word Lidar. It can be a single beam, multi-beam, or a triangulation Lidar, sometimes working up to several kilometers, shown on planes, satellites. But switching to industrial domain today, how Lidars are actually making things work. We were alluding to material handling and e-com industry a while ago. How do we actually make possible for articulated robotic arm or even a human being or a sorter or a gantry to actually assess the height, width, and length of an article moving speedily on a conveyor line? One thing is detecting something. Another is making a geometric measurement of that in three-dimensional space and enabling a right pickup without any accident or collision. So ladies and gentlemen, that's where the sensor world is today moving. That how can we deploy these measurement techniques actually and collate them to form a geometric image. Between a visual image and a geometric image, the difference lies in dimensions. The machines and controllers only understand dimensions. They don't understand just presence or absence, because the grippers actually have to work in tandem with the right pose and the right opening, closing, and the pressure. But not only that, what you are seeing in the middle of the screen on the right top is actually how the lidars measure each pixel, the distance and chromaticity, color, RGB color of each pixel, and thereby create a photograph, which is actually a geometric image. In a camera system, you are actually taking a visual image and doing data analysis of each pixel to calculate the distance and chromaticity. But in lidars, you are actually taking the distance and chromaticity to come to a complete picture. And why I'm mentioning this, imagine a cluster of robots or gantries operating. If we are able to create an image cloud that is accessible to different equipment working on a common cell, then each cell, each articulation actually knows what is the geometric dimension of each pixel. And that becomes very, very essential for effective automation implementation within the domain of Industry 4 and the machine. Some enablements or applications that I must share with you that are happening in modern day Industry 4 scenario are actually measuring by throwing a beam of light or a plane of light. Because most of the time, we are talking about Industry 4 can enable quality improvement. How does one do that? Actually, it's by corroborating shapes, sizes, dimensional checks, collecting the data, and also enabling the storage of data for a post-analysis or an online analysis for rejection or acceptance. A very quick example of something interesting that's getting caused day in and day out. What you see are coffee cups, whether the lid is there or not, because nobody wants to deliver a coffee cup without a lid. or in a real-time manufacturing, whether the classic age to the bearing has been applied, because that's the critical part what may decide the longevity of a operation or a machine. We just saw what an AMR is, but what makes this AMR move are something like these time of flight sensors and lidars, which are not only seen in one plane, but multiple planes. Because not only do we need to see what's ahead, we might need to see at an angle to predict forward what may lie on the top, or whether the floor is clear from some contamination or not as an AMR or AVD is moving. Same goes with a forklift or an assembly line. How do we assess? Having said so, moving on from the image part, there can be cameras of different genres. In fact, most of you are familiar with vision sensor, and as we have graduated slowly into more complex equipment, there have been smart cameras and multi-camera vision systems. But today, courtesy huge developments into optical chips and the onboard software, there hardly goes a year where a new genre or a generation of equipment is not coming forward, enabling a lot of, I would say, factory operations as we move forward. Just for a quick reference, I would mention detection and matching. You can see how these things come together to enable an operation on a conveying line or a robotic inspection or a gantry. The point here is not only are the chips getting better resolution, it's also how the onboard controllers are actually communicating. With better controllers, better decision capabilities, poor contamination or poor lighting, contamination in lighting, how decisive the machines and their visions are actually becoming. But that doesn't end how things are advancing. There can be general purpose cameras and vision systems, but there can also be process specific. We can take the same cameras and give a pre-built software within that, and highly optimized software, which is dedicated to the function a specific sensor has been tasked to perform. A lot of you must be familiar how two-dimensional barcodes today are being used as positioning system within a gantry, hanging conveyor, so on and so forth. Whereas the ultimate benefit of it is not only are we automating, we are actually able to closely control, monitor, deploy quickly, and modify quickly our own assembling line. That's where I would say these kinds of sensors start to come and play a pivotal role. I guess we're gonna go through this as we take more questions and talk about AMRs and EGVs. However, a lot of you are from the automotive world, and you know how tracing and genealogy is becoming important in automotive industry, whereas all products must be traceable down to every back-end production line, whatever be the assembly, sub-assembly, or a component. But having said so, Mr. Nachiket so beautifully explained in the morning how a dealer demand actually goes through, triggers the inventory, looks at the work in pipeline, and triggers the tier 2 and tier 3 suppliers as to what might be needed so that the right convergence happens at the right point of time. I'm happy to share that humongous amount of improvements have happened over barcode which is actually a very, very versatile way of carrying information, especially the 2D barcodes, how information is being stored, transported, and communicated across enterprise. The two kinds of huge changes that have happened in the erstwhile barcodes, which have been here for donkey years, is that readability of very small barcodes over longer distances and gathering that data and speedily communicating it over network. I guess that's what makes enterprise to enterprise or JIT or inventory management or a supply chain actually go around in that. Not only that, huge advancements have actually happened along the RFID lines, wherein open source, most of the times it's these days UHF, as the cost of ownership needs to be reduced, wherein in probably now at 10% of the erstwhile cost of tax, a UHF 18,060 UHF tax are making humongous progress and enabling a lot of process live in the manufacturing line. So UHF, RFID, barcoding, how they are being put in with the information, marked with the information, how information is getting carried, how intermediate controllers, servers are coming together and communicating that data is a tango which is worth seeing and appreciating. Last but not the least, I would share that there are different communication streams within an organization. But if the binary data or the process frontline streams are hogging on to the high-end networks, that will lead to a lot of problems and latency within our network. So what has really come about is a standardized network. You're familiar with IO-Link, wherein the data and the data communication and the power are actually running on the same lines, wherein it is enabling a lot of data from the sensors being communicated on the power lines, even taking the legacy sensors on board to lots of hubs, reducing the clutter in the plant, and making a very, very clean and nice, fast communication possible. Having said so, I guess then there are a lot of peripheral equipments that are today landing, increasingly making all our data gathering, collating, and uploading into the cloud or the machine cloud or the enterprise cloud as the need might be possible, and thereby readying the recipe for further implementation and plucking the fruits of Industry 4.0. Thank you all for your patient listening. I would hereafter invite questions, if I may, from the participants, please.
There is a question, Mr. Ravi, related to from Dr. Archana Bahuguna, who says, appreciate if you could share an example of application of robots in pharma manufacturing. So I just would like to say that, yes, I mean, the pharma industry is a big area, a big user of automation, specifically robots. We, from our company, we did a project at one of the leading pharmaceutical companies in India, where they had to paste these patient information leaflets on top of the medicine bottles. So it's a high-speed line where the medicine bottles containing the tablets are moving on a conveyor at a speed of about 80 bottles per minute. So it's less than a second per bottle. So in that, we had to apply a bead of glue on top of the bottle, and these information leaflets are folded by from a supplier outside the company, and they're brought in a box. So we had to pick them one by one and paste it on top of the bottle using a high-speed robot. So this application we did with the help of vision system and some of the technologies that Mr. Ravi has explained, vision systems and all kinds of sensors that we used, and a high-speed robot, end-of-arm tooling, which is flexible because it's not that the same bottle size comes in every time. The bottle size varies, the diameter, the height, the size of the leaflet varies. So the system needs to be flexible enough and sense the batch which is coming in. So this entire thing was integrated and supplied to the customer. This was in Hyderabad. And this customer is also using a lot of other robots for different applications in their manufacturing operations. I'm sure there are many more applications, but I just shared one that we had implemented from DiFacto.
Wonderful. Thanks, because proof of the pudding is in eating it. So thank you for giving us an example. In fact, taking some few minutes more, Mr. Virendra, if I can just quickly check with Ms. Marcia, talking about examples, and one thing very interesting was their structured and unstructured data. Ma'am, can you share with us any lighthouse project or an example that you have actually landed on this?
Yes, I mean, there are, in building automation, for example, they're taking our software and using it to not only monitor the temperature, but they're also taking the data from the weather and forecasting from the weather, the internet, forecasting whether the temperature in the building needs to be higher or lower, the lighting, if it's, raining versus extensive. So it's using unstructured data because this is imaging, it's weather, it's from other channel, and it's also using structured data, which is coming off of, the devices and can be put in a database and collected and displayed. So that's showing both unstructured data for building automation and structured data. I hope I answered your question.
Oh, yes, enlightening. Thanks. Mr. Vain, may I request for a couple of more minutes in order to address some of the queries? Thank you. One of the questions that has been parked is, that's directed to Mr. Gopalswamy. What would you put up as the criteria of selecting either an AGV or distinguishing it between an AMR?
Okay. Yeah, so it's a very customer specific. Thank you for the question. I think it's a very relevant one. The criteria for selecting a AGV over an AMR or vice versa, it depends on the application of the customer. So, for example, if the customer prefers that the vehicle should not stray from a given path and is pretty happy to have a structured environment where the vehicle is free to move, then an AGV would make more sense, because at one time it works very reliably. Secondly, it is cost effective because it uses a very simple guidance technology, whereas an AMR uses more advanced Lidar, the ones that you have presented in your presentation, those kind of sensors and the software that goes with it to understand the correlate with the pre-built map inside the AMR's software. So the AMR is used when you need a lot of flexibility, whereas an AGV will suit the purpose very well if it is for quite a predefined set of operations on a predefined set path. So it works perfectly fine. A lot of our automotive customers still prefer to use AGVs, but in some of the new environments like warehousing and logistics, AMRs are used. And we would like to see, as I showed some examples of AMRs being used in manufacturing. We think that these will we further come into use.
That's quite insightful. Ms. Marcia, you talked about a very structured approach onto different analysis and the fruits out of it. As the trajectory was going up in your graph, I started wondering, what is after prescriptive analysis,
Well, actually, it's cognitive analytics, and cognitive analytics is a study which applies human-like intelligence to certain tasks. So bringing together a number of intelligent technologies such as semantics, natural language, deep learning, reasoning. So what you're trying to do is mimic a human cognitive approach, and that's the next one is cognitive analytics.
Looking forward on that.
If I may,
That's not the least.
Ravi, if I may intervene,
Yeah.
prescriptive analytics, Marcia would be like an expert doctor, right? He's built up his knowledge over years and years of experience meeting various patients, and now he can look at the patient and then prescribe treatment. That is exactly what prescriptive analytics
Correct.
is.
You're absolutely correct. Prescriptive is saying, now that we know there's a problem, here's the steps to take to solve it. Whether a machine does it or it sends it to a human to do it, it's the same. And that's what prescriptive is, right? And you're absolutely correct.
There are a lot of questions which the participants have posed. Paucity of time, we'll try to get back to them individually. But as a sign off, Mr. Gopalswamy, what would be your prescription for flexible manufacturing or the future of it in India?
In India, is it?
Yeah.
Okay. All right. So, just my couple of thoughts are, robotics has been in use in Indian manufacturing for quite some time now. The penetration levels are still not at, the levels that are seen in countries like Japan, the US, and some of the Western world. So we have an advantage that we can engineer the solutions at given the cost advantage that we have. That's number one. Number two is, we are, like you mentioned, our society is quite open. At the beginning of your talk, you made a remark that our society is very open to new ideas. I think that's a very valid point you made, especially with the younger generation. They are so fast to learn things and adopt these technologies. I'm sure that they will be smart. They're so smart that they will adopt robotics, vision, the things that you talked about, 3D vision, data analytics that Marcia talked about, IoT. These will be adopted very, very quickly in India. And people will, they want to use the best in class technology. Our customers want to make sure that they're as competitive as the rest of the world. And I see that happening very, very quickly.
Thanks for the wonderful insight. With this, we come to the close of the session, and I really thank Mr. Gopalswamy and Ms. Marcia for throwing some valuable insights, sharing some valuable insights into how things are, and it's a building that's under a constant state of construction. So I wish you all the best and looking forward to furthermore developments in the arenas we have spoken about. Thank you.
Thank you so much.
Thank you.
Thank you.
Fellow panelists.
Bye-bye.
Bye.
Rendraji, you are not audible.
Not audible? Oh, sorry. Yeah. So there is one question in the chat box. What are the extensive benefits of Lidar and its major applications?
I guess that's
1 minute.
to me. I'll try to very quickly answer, Virenji. Lidars, depending on their functionality, can be of different types. you can have lidars that are seeing over kilometers in terms of land profiling. In fact, one of the latest discovery of an ancient site, which is about 4,000 years old in India, was actually discovered by aerial mapping through lidar. That's how these things function. Whereas in an assembly line, as I said, lidar is highly functional in creating a geometric image or giving a specific measurement data back to the controlling system. Now, the difference between a vision camera and a lidar is, in a vision camera, you have to triangulate and then assess with the onboard complex software what the dimension would be or the distance be. But the time taken for this processing is still quite a few milliseconds by the time the machine scenario changes. Whereas in a lidar operating out of laser, let's say over a few meter or a 10-20 meter, the results are instantaneous. So the machines that are operating on live data within a manufacturing closed under the ceiling area, it's the ready availability and instant availability of a geometric information. So depending on the functionality, one may deploy the lidar, if I'm adequately answering your query.
Thank you, Ravi-san, and this is some sort of from our side for your wonderful.
Mr. Virender, you are not audible.
Nah. Oh, sorry. It's so.
Yeah.
Please accept a token of
Thank you.
love from our side, Ravi-san, and this is Ajay-san.
Thank you. Thank you very much.
And I hope Marcia is still with us, or she has gone for a cup of coffee.
She's not there, sir. She's logged off.
Okay, no problem. She is at midnight, so she went for the coffee. It's okay. And now I will not take much time. Only I will request, because this session is too interesting, and we will find some capsule programs taking it forward for our industry again.